Welcome everyone to the next episode of About a Breakthrough. This and the next episode will be based on something that happened and stirred up the entire scientific community and socio-political situation of the world in the last century. Yes, I'm talking about Manhattan Project. I'm Shreyas and with me is Tejas. This will be the two-part series on the nuclear weapons.
Here is a sneak peek of what you will hear in this episode.
And you know what else was breaking down in around that time?
No?
The political and social integrity of Europe.
Szilard was like the Nostradamus of science, I would say. This guy actually had the potential to stop the consequences, the lethal and the deadly consequences of World War II as we know it.
So the way it happens is this particular reaction he conceptualized that it should generate more neutrons than it is fed to.
She was nominated 19 times for chemistry. She was also nominated 29 times for Nobel Prize in Physics,
where he imagined himself on trials for the crimes against humanity that his research led to such devastating things.
What a great guy. In 1939, Leo Szilard wrote a letter to the President of the United States at that time, who was Franklin Roosevelt. And this letter was also signed by Albert Einstein.
This whole story started with a discovery of a small tiny particle called neutron. Right, Tejas?
Yes, with a small particle called as neutron. And this neutron was the root cause of all the things which happened in World War II, and it was also responsible actually for ending World War II as we know it. So let's start with a brief introduction of how this neutron came into existence. Now, you may be knowing that there are three fundamental particles on a broad level if you talk about an atom. They're called as a proton, electron, and neutron. So we are going to talk about neutrons here today. Two particle physicists called Chadwick and Boseman, in 1932, they discovered this special particle which happened to be completely neutral as opposed to protons or neutrons. I guess the experiment is also very famous. It's called particle beam deflection experiment, where a radioactive substance is between two charged plates, and depending upon the charges, the particles go into the either way. But here, neutron goes totally undeflected, and this was the experiment which was done in 1932 to identify this particle called as neutron. Around the same time, Marie and Pierre Curie also discovered a phenomenon called as radioactivity. And if we want to check out more details on how they managed to do that, check out our second episode, The Curious Element, which is also available on YouTube and Spotify. So Marie and Pierre Curie discovered this phenomenon where if a certain kind of atom goes beyond a limit, it becomes unstable. If a certain kind of atom contains several number of protons, a specific number of protons and neutrons, it is no longer stable and it automatically decays into a simpler stable particle. This phenomenon is called as radioactivity. This was discovered by Marie and Pierre Curie around the starting of the 20th century. Fission is actually a process where instead of this happening naturally, fission is a process where you sort of artificially try to emulate this process. You start a trigger which in turn leads to radioactivity or which causes radioactivity. So all of this was pretty complicated, and all of this was, it happened in quite a chronological order, in quite a successional manner. So let's start with the first point where it actually all started nucleating. Two very prominent particle physicists by the name of Rutherford and Soddy first of all discovered that atoms are not solid blocks or solid building blocks as the understanding was there at that time, but instead atoms were fragile actually after a limit, and atoms could be broken down. And this was a very fundamental understanding that led to this concept of artificial radioactivity and splitting the atom as it is known more famously.
Right. And you know what else was breaking down in around that time?
No?
The political and social integrity of Europe. The entire Europe was going through this turmoil called World War I. There were a lot of social issues that were building up in Europe, and that had led to this problematic situation, and all of the mid and western Europe was just fighting amongst each other. The countries, Hungary, Slovakia, basically the countries where the World War One first broke out, were really war torn. During this time, there was a budding scientist by the name of Szilard, a very genius person who could foresee that this kind of social situation will not help his own scientific improvement. So he flew Hungary, which was very bad at that time. So he left
Right.
Hungary for Germany, and he there joined a civil engineering course. But he wasn't very keen in learning engineering, and soon he got bored of it. So he left engineering to learn particle physics, and there he started, he started this chain reaction, quite literally, for this entire series of events.
Mm-hmm.
So this Szilard is the person who first conceptualized a reaction, a self-sustaining nuclear reaction that can carry on multiple times until the end of the entire material, and you only have to trigger it once. So the way it happens is, this particular reaction he conceptualized that it should generate more neutrons than it is fed to. So basically, when you bombard
Okay.
an atom, yes, when you bombard an atom, something like a radioactive isotope of uranium with one neutron, uranium atom breaks down into consistent into smaller atoms, smaller elements, but along with that, it emits three other neutrons. So these neutrons go ahead and bombard another uranium atom, and the reaction is continued. So
Okay.
this, now we know the particulars about the amount of neutrons and uranium and radioactive isotopes, etc. But at that time, Szilard just had a, some vague idea, and he kind of conceptualized the entire thing, but he couldn't work out the details at that time. But to further study this, he then went to London, because Germany was taken over by Nazis, and in
Right.
London he actually patented this entire reaction. Then he submitted this patent to the British administration. He saw the potential of this entire thing of being used as a weapon.
Mm-hmm. Now, I would like to add something here. A lot of our viewers might be interested in knowing this, that since Szilard was a scientist, shouldn't he well be aware of the capabilities and the harm that this nuclear reactions could cause? And why would he therefore go to patent such kind of reaction, which is so much distressful, which can be so much distressful to the humankind? And the answer is,
Right.
for the exact same reason that it can be distressful, he went and patented it because he thought that this technology is so lethal that it must not fall into a destructive hand. And that's exactly why he patented it, so that others could not use it in a harmful way. And moreover
Right.
to his personality, Szilard was like the Nostradamus of science, I would say. He could see many potential failures in political and social regimes. He could see many discoveries a lot earlier than they actually happened. So, for instance, you mentioned that he flew out of Hungary when the
Right.
situations were not that good. And I guess it was the same thing with Austria as well. He was also researching in Austria, but given the political conditions, he also flew out of Austria as well and went to London.
Right.
He was so well aware of what's going on around him, and it's this guy actually had the potential to stop the consequences, the lethal and the deadly consequences of World War II as we know it today. This guy had the capacity to do so, but we'll see later on in this episode how it eventually fell out of his hands and how situation got worse and worse and worse, and they had no option but to develop this element. But Szilard could have been the savior in World War II,
Right.
but it was very unfortunate that he couldn't. And how
Definitely.
important, yeah, I also want to stress how important it was, that you mentioned, to envision a self sustained chain reaction. I see this experiment almost as if a composer is making a composition. You have the notes with you, you have your instrument with you, but it is not anybody's game, it's not anybody's piece of cake to compose a great melody, right? And in this case,
Definitely.
even the notes were not visible. You had the bits and pieces lying here and there, but to envision this was on the level of art. So we have mentioned this reference so many times, but once again, this was science or technology being applied to a level of art,
Definitely.
right?
To come
Mm-hmm.
up with something from scratch as we've said in earlier episodes, you need to be creative, definitely.
Yeah,
So
right.
Szilard was that kind of a guy. He later went to
Hmm.
United States. Coming back to
Yeah.
the entire phenomena, I guess along with Szilard, Irene Joliot Curie, the daughter of Marie Curie and Pierre Curie, and her fiance, I guess then fiance, then husband, Frederick, were also bombarding atoms with particles, right?
Yes, absolutely. And I was coming to this. Irene and Frederick Julio Curie, couple once again was also interested in and investigating in particle physics research. And you can also guess that entire Curie family was this source of this radioactivity, and they have been there all along. So Mary and Pierre's daughter Irene and her husband Frederick were trying to investigate how they can actually split this unstable atom, and they found a way actually. What they did
Right.
was they bombarded a particle which is called as alpha particles, which is basically nothing but a helium nucleus, onto these unstable atoms. And what they did was it also triggered a chain reaction, which is similar to what you're explaining a little while ago. But what it does
Right.
is basically kind of it's like slamming a train into a car. So the car just ruptures into pieces, right? So it's the similar analogy what we are
Right.
talking about. Bombarding a helium nucleus or an alpha particle into unstable nucleus. That was one way to go. Simultaneously, independently, also another great particle physicist by the name of Enrico Fermi and this guy which you mentioned, Szilard, they were also simultaneously experimenting with this stuff, and they found that neutron was the key. Neutron was actually the answer to the puzzle. So what they did was,
Right.
just like Irene and Julio bombarded alpha particles, they bombarded neutrons instead of alpha particles onto these unstable atoms. And this was a much better process. This was a much more efficient, sustainable process which they achieved.
Right.
Finally, to put the full stop and finally to have the cherry on the cake, three another great particle physicists by the name of Lee Smitner, Otto Hahn, Frisch, they also in 1938 discovered the first complete methodology to have artificial radioactivity. This was, of course, a great feat, but so I would just like to add one point here about this great particle physicist called Lee Smitner. She was, of course, a woman, and we have talked about how gender bias was prevalent during that time in Europe.
Right.
It is mind blowing to know that she was. Can you make a guess how many times she was nominated for a Nobel Prize?
3, 4?
Well, even I was surprised when I read this first. She was nominated 19 times for chemistry
Oh my
between
goodness.
1924 and 1948, and it doesn't even stop here. She was also nominated 29 times for Nobel Prize in Physics between 1937 and 1965, but she never won.
Wow.
She never
All
won.
those nominations and not a single prize.
Not a single prize. Can you imagine this? I mean, this is like we're talking about 48 nominations for a Nobel Prize and not a victory.
Wow.
I mean, she
And
must have.
I can't believe it wasn't that long ago, right? It's
Yeah.
barely 80, 90 years ago.
Yes, 1965 was
Wow.
was her last nomination. So you can get an idea of
Right.
how great the idea of struggles, the extent of struggle that Lee Smitner must have forced to go through. It was, it was not a easy life for her. But she indeed, as been talking about this for a long time, that intelligence overpowers this social stigmas and social constraints all the time.
Right.
Lee Smitner was absolutely, without a doubt, the genius of a century in her domain, and her intelligence was, of course, did shine irrespective of all these
Right.
adversities.
I mean, she's now commemorated in the periodic table. I think the element number 109 is named after her.
Mm-hmm. That's right.
Yeah. I mean, that was unfair, wasn't it? The society was structured and functioned back in those days. And even today, it's not way better than that. But I guess we are still on the way to making progress, and that does count. But yeah, we have a long way to go.
Yeah, I agree with you. We are getting there slowly.
Right. So this entire story, now time that the whole process was conceptualized, the contribution of these three people was mainly that is relevant to this story was that when Szilard first found out, he was thinking of barium, splitting barium, but that process wasn't very self-sustained because it did not generate enough neutrons to keep the process going. And
Right.
these people found out that instead of barium, it could be a heavier element, something like the uranium 239, which is the radioactive isotope of uranium.
Right.
So yeah, I mean, that was one of the main things that came out of their researches. Funny story, Szilard and Fermi later on went to develop the nuclear reactors, the very first generation of nuclear reactors to generate, sustainable, low carbon footprint energy. I think that was their way to, help themselves, get rid of the guilt, but eventually
Redeem
that wasn't
themselves essentially.
sufficient. Yeah, I mean, Szilard had written a short story in 1950s saying "My Trial" as a war criminal, where he
Oh,
imagined himself on trials for the crimes against humanity that his research led to such devastating thing.
what a great
So,
guy.
right. It fascinates me sometimes that great minds like this who have done very, very big things, be it Szilard, be it Robert Oppenheimer or Einstein, all of these people, they used to think about their social standpoint so much that, you know, despite of entire atomic bomb decision not being taken by them, they find themselves guilty of, doing that.
A lot of people in society today think that the destruction which happened due to nuclear weapons, if scientists were not to discover it in the first place, no destruction would have happened. And while that may be true,
Right.
it is not entirely a fact to be consumed directly. A scientist's job is to explore and to understand the secrets of universe. His job is not to develop a weapon out of all of this scientific phenomenon. So reactors are even used today in nuclear submarines. They are used to generate power. Everything is going well even today, even though we have discovered nuclear reaction. It was an unfortunate fate and
Right.
politics and war-like situations which forced these scientists to use their discoveries in this unintentional manner.
Definitely. I mean, it's kind of weird to think that something that caused destruction of humanity on such a massive scale and then change the way the world is, it's the same thing that is propelling humanity further into the space. Can you believe that?
Right.
Something can be so destructive at one hand and so powerful, so constructive in the other side.
Right. So I guess it's a two-edged sword. It's up to you how to use it.
Right, the
You
double-edged
can, yeah,
sword,
the double-edged
definitely.
sword. Right. I mean, mechanical engineering, you can use it to create crazy weapons, or you can also use it to create a heart stent or an angioplasty equipment which saves lives. So it has always been
Right.
that way, and it was just unfortunate that situation forced all of this to the tragic end that we know.
Nowadays we have so many ethical protocols in place to avoid such kind of uses, but we were not aware back in those times, I must say, that something that can be discovered that would be so powerful, and how to avoid that going into bad hands, and the social or the political agendas driving it to cause destruction. Something that is similar in current world, I guess I can say, is the genetic research. I mean, you can easily create one of the most terrifying bioweapons right now. Like right now we are witnessing what kind of destruction it can cause, and this is a natural one. Imagine an engineered virus that will be spread through it. But the same genetic engineering can be used to get rid of some of the most pressing issues of humanity, something like aging, the cancer, or
True.
the other viral diseases, something like HIV, that we've been, I mean, it's been difficult to fight off.
Right.
The same thing can be used in two ways, and we need to be very, very careful so that it is only used for a good and not for the bad.
Absolutely right. I'm with you on this point. Absolutely. So we started in 1932, and right now we are in 1938, where Lee Smitner, Otto Hahn, and Frisch have discovered artificial radioactivity, and now the world started to realize that this has to be a serious business. This can be turned into an extremely lethal weapon. If not used by correct hands, it would cause destruction like never before. And Well, who could be the first one to realize this? It was once again Leo Szilard. So, in 1939, Leo Szilard wrote a letter to the President of United States at that time, who was Franklin Roosevelt. And this letter was also signed by Albert Einstein. And the letter contained the possibility of this phenomenon being used as a weapon of mass destruction. And he also suspected that the Nazi counterparts in World War II could actually create a weapon of mass destruction like this, and therefore the entire world could be put in danger. And therefore he requested Roosevelt to take a look into this matter immediately. So what followed after Roosevelt received this letter? How did we end up in creating the Manhattan Project, which included some of the most famous minds of all time, like Dr. Richard Feynman, Dr. Robert Oppenheimer, Einstein himself, Szilard himself? Why did all of these great people came together to create weapons of mass destruction? Well, we can't tell you everything just yet. You have to stay tuned for the second part of this episode. And that's all we have for you today. Be sure to subscribe to us on YouTube. We are also there on Spotify. Go listen to us and follow us there on Spotify. If you have any suggestions, if you have any comments, if you have anything that you would want to tell us, please write to us directly, or you can also mention your thoughts and comments. Thank you and have a great day.